Hello, thank you very much for having me here. My name is Bernardo, I'm co-founder and AI lead at Flow AI. Today I'm going to talk about agent harnesses. The title of my presentation is Context is King, but harness is king, but context is still king. I don't want Billy and Aro to get mad at me. But context doesn't show up by magic, right? Something has to find that context, like fetch it, format it perhaps, store it, validate it. Most importantly, something has to decide when and how much of the context the model should see. That's what we are starting to call the harness. What I like to basically show today is that for production agents, if you specialize that harness, you can get a lot more out of the same model. And I'm going to make now that visual with a concrete example, but I just want to make clear that during the presentation, I'm going to use Flow AI as an example, because of course it's the system that I know the best. But the goal is to share basically patterns that generalize and you could basically use and apply to your own harnesses. So here we can see two agents that are working on the same task, same data, but they are built with very different harnesses. The agent on the left could be built with a harness, for example, for excelling at coding, like Claude Code or Codex. And it clearly has this behavior of exploring broadly, collecting a lot of information and context before it returns an output. But the other agent instead, it quickly resolves products and channels in parallel and then stores a type plan and asks for approval. So both agents, you can see that they are capable because they get to similar answer, but I'm going to argue that capability is very different than fit. A user, for example, inside a SaaS product that is interacting with an agent built with the harness one, could read that behavior of broad exploration as something that is slow and inefficient, and it would be asking okay, the agent spent 90 seconds searching, but it didn't even ask for my input or anything. So that means that the harness one has defaults that aren't really aligned with the expectations of the user, and that's why I'm saying that capability is different than fit. I'm going to spend just 1 minute on the definition of harness because it's a relatively new term. Pretty sure that you've heard of it, but I like to use my definition for this presentation, which is that the harness is like the behavior layer around the model. So a framework, for example, gives you primitives for building any type of agent with your own opinions, like tool calling, for managing a state, retries, etc. But the harness comes with encoded defaults. And I like to think about those defaults as opinions about how your agent should behave. For example, how it should plan, when it should ask for approval, and how often, etc. Hopefully, those opinions map to your desired agent behavior, right? So now, let's go back to the topic. Capability is different than fit, as we saw in the first example. So how do we solve this problem? One of the solutions is specializing your harness. And the pattern that I think you can use for that is, first of all, naming the failure mode. So you can look at the agents and the harnesses out there. You could try them and see, okay, this agent or this agent that I built with this harness is actually making this mistake or is searching inefficiently. So then I'm gonna map that to my desired behavior. What should this agent do by default? What should be the default that is encoded in the harness? And then you go and create the harness feature for that to encode that behavior. I'm going to say that how many of you have built an agent in the past, with a framework? Many of you, right? So pretty sure that when you were building that agent, you were actually encoding your opinions into how, into that implementation, how the agent should behave and work. So as I'm going to use Flow AI as an example, just a bit of background so you can understand the samples that we are going to see. So we work with SaaS companies that sit on top of a lot of proprietary data and predictive algorithms. For example, the users would ask things like, change the price of thousands of SKUs and then like simulate the demand, or find like anomalies in the last quarter's bookings, or I don't know, running like what-if scenarios. The agents need to be able to handle like a lot of large structured data, but they need to reason over that data using business rules and domain knowledge. So they need everything at once, like at the same time. They also need to keep humans in the loop because the agents are going to be executing actions on the platform on behalf of the users. So just now that we have the context, I'm going to show you this view of inside our harness, but the important thing here is not like the exact architecture of our harness, is that each of these boxes that you see here, you can specialize them for your particular use case. Like you can decide how you inject your context, like how you store it, how you store large context. Do you keep it in all the context in the context window, or are you able to resolve parts of it outside? So this is like where you can encode your default behaviors. So for the rest of the talk, I'm gonna go like a bit deeper into 3 opinions that we encoded in our harness and the implementation choices that led to this. So when we started working on this, we said, okay, like we are working with complex database schemas. It's gonna be enough that the agent is able to understand that schema and basically run like accurate queries. Well, it wasn't, because there's a lot of ambiguity in the queries that we get. We actually need a semantic data layer that has, of course, like information about the schema for the agent, but also organizational knowledge and business rules. And it has to be, all these sources of information has to be in a format that the agent can retrieve and then act on. So let's say that one of the users of these kind of SaaS companies where we deployed like the agent harness, so they say like decrease price of slow-moving snacks across all retailers. So this query is quite ambiguous because you have slow-moving. Slow-moving could mean something very different to one organization to another. You also have, snacks, what's a snack, etc. So the agent needs 3 things at once. So one is the organizational knowledge, and this is the vocabulary of the company. In this case, like like how you determine if a product or a set of products are like slow-moving. Business rules, this is how you compute things like CAP formulas, the rounding policy, or the fact that you should never like average prices across different channels. And also the schema, like of course tables, columns, like how you join them, etc. So the job of the semantic data layer is basically to store all these sources of information in an agent-ready format and connect them together. So this is an example of what could be like different items in the semantic data layer, which is like it's like a graph of the model level. You see here a column in the fast scenario table with a nice business-friendly description, and then there is a rule, a business rule that applies to that particular column for like using max, not average, for CAP checks. And then we know that that rule comes from a document, and that document might have more rules that might be relevant depending on the query. So how can you go from like all these kind of raw sources of information or inputs to this connected searchable layer? So 5 steps. So the first one is profiling. So we connect to the customer's database and run statistical profiling. And then we have an LLM-based process for enriching all this information with nice natural language description, so the agent can reason better about the schema, but also like the business meaning. Then we ingest documentation, like everything that you could think about, like how the agent should operate, any knowledge that is required. And then after that, there's a process for extracting different types of items that we have in the semantic data layer. So it could be like a knowledge rule, could be like a business rule for calculating certain things, could be a metric like a SQL predicate for calculating, I don't know, like how we calculate revenue here, things like that. And then we index everything, so we have like multi-pattern keyword matching, We have tags that carry the instant type, and of course the foreign keys and the structured relations that form the graph, as I said, at the model level. And finally, there is a toolkit. And it was really cool to see in the previous presentation, like we were talking about agentic search. So this toolkit enables agentic search, but on top of our semantic data layer. So we can see how the agent would use that layer. So we have similar query here, and you see how the agent would use a tool for searching knowledge, finds like the glossary entry, and then it resolves like snacks, which is a segment, and then all retailers, and then it quickly creates a type plan. And you can see references here. There is a product set ref, there is a scope set ref, and a plan ID. Hold on to those because they are gonna like become very relevant in the last opinion that we are gonna talk about at the end of the presentation. Second opinion, and probably the one I'm most excited about, is it's about continuous learning, but continuous learning for the semantic data layer. So because organizational knowledge changes and evolves like all the time, we need our semantic data layer to do the same. But we need to do it in a safe that is in a way that is safe, gated, and auditable, because it's organizational knowledge, and that means that that knowledge is available to all the users of a tenant in the semantic data layer. So here we can see how a user is asking for a price increase and is asking to cap it at 14 euros, and then the agent went and created a plan using average prices, and then the user is pushing back and saying, hey, no, actually this is wrong. You should use max. You should never average across sales channels. So we implemented a way of scanning traces and detect these user correction patterns. The process of detecting this is very simple. We just look at the user messages and use LLMs for classifying that. And then we use LLMs as well for generating proposals, either for new knowledge in the semantic data layer, but also for updates to existing knowledge. We add that to a queue, and there is a human gate. So there are experts reviewing that information and deciding if that correction should become part of the organizational knowledge. If they approve one of these, then we trigger an update flow. The knowledge becomes instantly live for all the tenants, for all the users under that tenant. Third opinion, which is the last one, it's about how we manage large context in our agent harness. When we put this type of agent in front of real enterprise data, we made a mistake. We were kind of filling the context window with IDs, segments, etc., because we needed them. We needed all of them for downstream processing. And then we realized that, okay, we are using the context window as storage when we should use it for reasoning, right? Also, if you want to go deeper into the topic, there's a really nice talk by my co-founder Carlos in the first edition of Context is King in Helsinki, so I do recommend it. And yeah, this is how it breaks. This is what could happen. We might call this search products tool that returns more than 70K product IDs. And the thing is that we need all those IDs for then creating actions and plans. But we cannot keep, obviously, all of them in the context window because it would blow up, basically. So how did we solve it? Well, before that, why cannot we use the obvious fixes for long tool outputs? It's because it's indivisible data, as I said. We need the exact set of data. We cannot truncate, we cannot summarize. It doesn't make sense also to use a model with a bigger context window because it's inefficient, there's quality degradation, massive latency increases. So the solution was to apply a very old pattern in software engineering, which is using memory pointers. So we were seeing, okay, we are filling the context window with these IDs. Doesn't make sense. So let's put all of them in a set, like a product set, and then let's work with a pointer reference plus a glimpse. So the data glimpse is a dense statistical summary of that particular set, And the goal is that it keeps the reasoning of the agent intact. So you can see how now, instead of having 50,000 IDs, we have a 24-character pointer reference plus a data glimpse. And we apply, obviously, a similar pattern to context, to agent handoffs, as other harnesses do as well, obviously. So instead of passing the full plan, we pass a plan ID, and we resolve all the actions in that plan outside the context window. So to close this presentation, I want to emphasize that the harness is where the leverage is. Right now, there are, of course, powerful harnesses out there like Cloud Code, Codex, and others. I mean, I use them every day, all of you as well. But remember that the capability is not the same as fit. The defaults are likely not tuned for your use case if you are building a customer-facing product. So you're going to have like unique requirements. Your users are going to have different understanding of what fast or safe is. I think those expectations and those opinions should be encoded in your harness. That's everything from me. Thank you so much. I'm, of course, happy to take questions.
Excellent. Thank you so much, Bernardo. Now we have time for questions. So who wants to go first? Just raise your hand. We have one there all the way back, so I'll sprint there.
Great presentations. In your workflow, one of the steps was ingestion content, and you showed PDF and words and text and markdown files. So
sorry, where are you? I cannot see you. Where
right here at the very end.
Sorry. Yeah, sorry.
Yes, sure. So my question is, how do you ingest PDF? Do you have your own, like a parsing tool, or because the PDFs that have like text ingesting and getting content is easy,
yeah.
But what if there are tables and pictures, and what do you do with the more complex PDFs?
Yeah, so we try to work with, so we have some flexibility there when we work with our customers. So we can look at the quality of the PDFs and see if there are many images, tables, etc. To be fair, we have flexibility there, and we could say, you know, instead of, because we work at the moment, we work quite closely with these customers, we could say, okay, maybe we need to clean this up a little bit and have like a more kind of structured text. So it's not that we haven't really developed like a really, you know, sophisticated solution for handling these very complex PDFs that I know it's a big problem. So the PDFs that we work with are usually quite simple, just text, not a lot of tables or images.
Excellent. Do we have more questions for Bernardo? There's one. I need to go from one end to another, so just bear with me.
Really cool presentation. Who's your intended customer? Like, who do you guys sell to? Is it bigger companies where you have big analytical teams and they have the resources to adopt a totally different harness for that team, or are you more going like PLG, like anyone who's an analyst, or even like anyone who's not an analyst who has an analytical workflow, you'd be like, hey, you should use Flow?
Yeah, so our target customer is a mid-size SaaS company that, as I said, has a lot of proprietary data and predictive algorithms. So they expose that data through either dashboards or, you know, APIs. They are feeling a lot of pressure to now like provide agentic experiences. They don't really have like a lot of AI talent in-house. They are not planning to create a big AI department either. So we specialize our harness for that particular use case. So their engineers, their software engineers can take it, configure it, like provide all the domain knowledge that they need, and deploy like their agents, like embedded in their products.
Awesome. I have another quick follow-up question if we have time. Yep. Like in Claude Code, so like in our team, we're constantly talking about like which harness is everyone using, why, like for which workflows, etc. So at the moment, we're sort of settling on Claude Code. One of the reasons is plugins are very easy to distribute across the team.
Yeah.
Like, are you seeing this? And like, also that I think it's becoming a moat for Claude, to be honest, that we're building so many plugins that it's going to make it harder and harder for us to switch to a different harness. How are you guys thinking about like moat for the harness and like transition from a different one to yours?
It's a very interesting question, because there's also like this debate that like all SaaS products kind of be like pulled into the chat interfaces. There is something that we developed that we haven't really like, offered yet, which is like instead of just the harness, like the full harness, it's like a harness extension for Cloud code and codex. That's something that we are looking at, but one of the issues, for example, is that the companies that we are working with, the agents become like really core to their offering, right? So they really want to own it. And if you go with the harness extension approach, for example, you are losing like observability, you are losing like evals, or you are just like forced to use whatever Anthropic or OpenAI is going to offer. So it's a bit of there's a bit of tension in that regard for these companies. So I don't know right now, but maybe let's see how the field like evolves. But yeah, it's a good question.
Excellent. There's still time for one more question. So if anyone wants to shoot a question, happy to run to the other side again. Feel free to raise your hand. Here we go.
Yeah, I'm curious, you were talking about the semantic data layer and how organizations, their understanding of context of business matrices and definitions change over time. How are you envisioning an end user interacting with Flow AI to kind of like give it that context and even visualize, like in my experience, it's like you might have 4 different departments have 4 definitions for active user, and they're all actually correct.
Yeah.
For all 4 of those different teams, but when you go across those teams, they're wrong in a sense. So I'm just kind of curious how you're imagining the semantic, like what does that user interaction actually look like? Is it as simple as they just talk to the agent through like some sort of interface or through MCP, or kind of like I'm just trying to visualize it. Yeah.
Yeah, it's a great question. Before I answer it, I'd like to clarify that we basically work with a SaaS company that then they deploy their agent and then they have more customers. So they are also like serving many different customers. So for example, our customer is going to have many tenants basically that are their customers. So the whole system is multi-tenancy, it's multi-tenant by design. And it's basically at the data level, but also at the orchestration level. So the semantic data layer is multi-tenant. So when you initialize one agent with our harness, that agent cannot have access to like organizational knowledge of another company, and it cannot have access to the threads that like a user under another tenant was creating. So that's how we like are able to, for example, let's say that we are working with a company in the hospitality industry, and they are serving different restaurants. Each restaurant can have its own organizational knowledge and its own ways of, calculating certain things. And then that's at the organizational level, but then there are also user preferences. So each user, of course, can have its own preferences when interacting with the agent. And one of the processes that we have for collecting that information is that they can flag that out using the agent. They can use a command for submitting a correction as well, or submitting a preference, and the agent will be able to detect it and, either store it or send it to the queue for review as well.
That makes sense. And then you have sort of like access control layer where like the data stewards are declared, and they can kind of like gate, more formal changes to matrices and definitions.
Sorry, say again. I didn't
like I'm imagining then you also have like a data steward level who then like they'll basically have like a human in the loop that will review and approve if like they want to change a metric definition at an org level or something like that.
Yeah, there are like we work usually with different like hashes for like identifying like multi-tenants, and then we can use that for managing all that.
Excellent. Thank you so much, Bernardo. Let's hear one more time from Bernardo.
Thank you.